Hello viewers, in this lecture I will let you know that how a MATLAB code can be designed for the approximations of Caputo fractional derivatives. This is the research paper that I have already explained in two of my previous lectures. In this lecture, our major objective is to know how a MATLAB code can be written for the numerical Caputo fractional differentiation. So let me show you the definition for the Caputo differential operator. In this research paper, the definition is shown by equation 1.13. This is what we call Caputo fractional derivative of order alpha, where alpha is a positive real number. So you can see on the left-hand side of equation 1.13 is what we call the symbol for the Caputo fractional derivative, the differential operator that carries the power alpha, which is the fractional order, any positive real number. It is defined in these two pieces. So you can see here the first piece comes when alpha lies between m minus 1 and m, where m is a positive integer. And when this m and alpha both are equal, we get the mth order derivative for our function. In other words, we go back to the classical calculus. Now the scheme proposed by the author for numerical Caputo fractional differentiation is given in theorem 3 of this research paper. As now you can see on the screen, theorem 3 equation 3.1 is the general scheme. This is what we call Caputo fractional derivative rule. In this general scheme, if you substitute alpha to be any number lying between 0 and 1, then this general scheme 3.1 reduces to the scheme shown by equation 3.4. So now I will let you know that how we can convert this equation 3.4 into few lines of code in MATLAB. So in MATLAB, I have solved example 2 as you can see on the screen. A function sin x I have taken. Shortly I will show you the code where the alpha order derivative, the Caputo derivative of the function sin is given by equation 3.8 by an infinite series. This is the exact derivative, exact answer for the Caputo fractional derivative of order alpha for the sine function. And equation 3.8 comes when alpha is between 0 and 1, and you will get equation 3.9 when alpha is between 1 and 2. So let me show you the tabular data. For example, the half derivative of the sine function is being computed in table 3.1 with several step sizes. So if you focus on the first row of table 3.1, then you can see that 10 points are taken with a step size 0.1 and the approximate value is 0.8453 and so on and so forth, while the absolute error is 0.000674 approximately. So let's go to the code, and starting from line number 12, you can see I have mentioned here some of the important inputs, such as step size 0.1, the initial value for x 0, the final value of x 1, the interval, the domain of the function is from 0 to 1 with a step size 0.1. K shows the number of points. Alpha fractional order. And now the important lines, of course, are the lines that I have highlighted. And if you compare these lines in the research paper with the equation, with the devised scheme, you will come to know that I have written the similar terms. So we have to be little careful about the brackets. Apart from that, it is easy to write the scheme in MATLAB. After that, I have also written the actual answer so that I can find the absolute errors. So this exact answer was also mentioned in the research paper. So after writing the exact answer, I have given the command to compute absolute errors. And after that, you can see on line number 29, I have collected the computed information. So let's run this code. Go to command window to see the results. So you can see the number of points 10, step size 0.1, approximate value for the Caputo fractional derivative of sine x, and this is absolute error. And these four numbers are exactly same that are given in the first row of table 3.1. Let's confirm the second last row by taking the step size 0.0125. So let's go to the code and change the step size 0.0125. Let me once again confirm 0.0125. Yes. So let's run the code again. Go to the command window to see the results. And now you can see these are the same results that are mentioned in the second last row of table 3.1. So that's it. This is all about the code called Numerical Caputo Fractional Derivative. You can play with the code by changing the function, the step size, the domain of the function, the fractional order, and if you are choosing the fractional order lying between 1 and 2, you will have to change these lines of the code slightly as the scheme in the research paper is shown for alpha that lies between 1 and 2. This scheme is when alpha is between 0 and 1. So that's it. This is all about the MATLAB code for the numerical value of the Caputo fractional derivative of a function of arbitrary order alpha, where alpha here in the code is taken to be 0.5. Finally, I would request you to like, share, and to subscribe my channel. Thank you so much for watching the lecture.